My name is Radley Horton, and I'm an associate research professor at Columbia University's Lamont-Doherty Earth Observatory. Extreme weather events such as tropical storms, heat waves, heavy rain events, and drought threaten the economic livelihood of our nation and the health and safety of our communities. In 2017, Hurricane Harvey inflicted an estimated $125 billion in damages, with 200,000 homes affected. In 2012, a drought caused $33 billion in losses, affecting multiple states. In light of the growing federal, state, and local costs of extreme weather events, continuing forecasting advances and enhanced communication of scientific information with decision makers are necessary preconditions for the increased preparedness, improved disaster response, and long-term resilience we're discussing. And continued forecasting improvements of extreme events will require new data from the atmosphere, the ocean, the land, and the cryosphere, as well as improved models that can better reproduce the key physical processes and the ways that they interact, and also interact with the complex human system components. So to give one example of those complex system interactions in the western U.S., including Colorado, the observed increase in extreme wildfires since the early 1980s. These large fires are indeed putting human safety and assets at risk, with potential cascading impacts across insurance markets and public utilities. Weather and climate are clearly a big part of the story, as today, when an individual weather system passes through, it's facing a new baseline of higher temperatures and reduced snowpack that have essentially stacked the deck towards an easier ignition of those fire systems. But forecasting fire risk also requires integration of other environmental data, such as historical forest management decisions and changes in the risk of new ignitions as people are moving to previously wild areas. As another quick example of system interactions, the surface of the ocean has warmed more than 1 degree Fahrenheit since 1900, which again loads the dice, this time towards heavier rain events that penetrate far inland, also towards combinations of high heat and high humidity that put our vulnerable populations at risk and threaten overall outdoor labor productivity as well. But as the Weather Bill of 2017 notes, advances in our scientific understanding of extreme events alone do not ensure societal risk reduction. Working with communities and businesses to help ensure that the most useful information is being generated and that it's being communicated as effectively as possible for diverse audiences, thereby adding value to existing federal investments in scientific research, is critical. One quick example is NOAA's Regional Integrated Sciences and Assessments Program, or RISA. A team in the south central United States worked with the Strategic Petroleum Reserve to identify strategies to secure the nation's 32-day, roughly $33 billion value supply of oil in the face of hurricane-related storm surge along the Gulf of Mexico. In the remainder of my time, I want to further emphasize how small shifts in long-term average conditions, what we call climate, can have a large effect on the frequency and magnitude of extreme weather events. It follows that if we hope to reduce economic and safety risks to the nation, climate must play a central role in research on extreme weather and its impacts. Since 1900, global temperatures have increased by about 2 degrees Fahrenheit. So far this century, just with that small change, the U.S. has seen twice as many record-breaking high temperatures as low temperatures. It's a similar story with sea level rise. We've only had an average change of 7 or 8 inches globally in sea level. It may sound like nothing, but as shown in Figure 1, for some locations, the past 2 generations have witnessed a 5 to 10-fold increase in the number of days with nuisance flooding that disrupts business, transportation, and critical public services. Now let's look at the future of coastal flooding, the next slide. And instead of looking at nuisance flooding, let's look at the big coastal floods, the 1-in-100-year events, the heights that flood insurance and zoning decisions are based upon. Even under the most optimistic sea level rise scenario imaginable, of 1 to 2 feet of sea level rise by late this century, we see here that across the entire U.S., events, high water levels that used to happen once every 100 years are going to be happening within the lifetime of the typical 30-year mortgage. And in some places, those high water levels could happen once every couple of years. Along the coast, our homes and critical infrastructure are all vulnerable. And it's but it's all Americans who suffer the economic costs of sea level rise. It is, after all U.S. taxpayers who bear much of the bill for coastal damages. And if ports are damaged, we can expect broader supply chain implications and economic disruption well inland. Fortunately, through investments in science and science communication geared towards decision makers, there's great potential for risk reduction and new opportunities across the U.S. economy. Moody's Investors Service, a major credit rating agency, has put cities on notice that if they do not plan both for historical extreme weather events, but also for emerging weather and climate risks, their credit ratings and thus ability to finance future expenditures may be at risk. Growing numbers of investors and companies are now making similar demands, while recognizing the opportunities for first movers in this space. Thank you for inviting me to testify, and I look forward to our discussion.